In this video, we will see a problem in which law of machine is given. Here we have a question. A machine has a velocity ratio of 20 and it has a law capital P, which is effort, is equal to 0.05 W. Here W is load plus 15 Newton. Calculate load lost in friction when 200 Newton load is lifted. Also calculate ideal effort. This is the question in front of us. Whatever is given here, I will write that in the form of data. So get started with this problem. A machine has a velocity ratio of 20. So VR is 20 and it has a law. The law of machine, I'll write it down. It is given in terms of Newton. It means effort is in the form of Newton. So if we know the value of load, we can calculate effort here. Calculate the load lost in friction. The question is, we have to find out the load lost in friction when 200 Newton load is lifted. So load value is given 200 Newton. Also calculate ideal effort. This is the second question. Ideal effort. So this much is the data part. Now we'll start solving this problem. Solution. I'll write here, since the law of machine is given, so therefore I'll use the formula P is equal to 0.05 W plus 15 Newton, because law of machine is given to us. Now therefore P will be equal to 0.05 into W value. It is given as 200 plus 15. So from this law of machine, I am able to calculate effort as load is given. So the value of effort is, it is 25 Newton. Now, after getting effort, the first question is load lost in friction. So I'll write down now, since load lost in friction, it is given by the formula W suffix F is equal to ideal load minus actual load. Now again the concept, for ideal load I'll take mechanical advantage is equal to velocity ratio, because ideal load is there in case of ideal machine, and for ideal machine as efficiency is 100%, so mechanical advantage is equal to velocity ratio. From this I will get the formula of ideal load. So W upon P, which is MA, is equal to VR. Finally W is equal to P into VR. This W I'll write down W suffix I, which is ideal load. So here I have the formula. I'll say that therefore load lost in friction is equal to ideal load is P into VR minus W. So therefore I'll put the values here. I'll put it onto the next page. So therefore load lost in friction is equal to, it is P into VR. P is 25 Newton, we have calculated. So 25 into VR value, it is 20 given, minus load, which is also there, it is 200 Newton given in the problem, minus 200. So from this I will get load lost in friction, and my answer is 300 Newton. That's the first part of the question which has been solved. Answer number 1, load lost in friction. Now the second part is, they are saying to calculate effort lost in friction. So I'll write down, since effort lost in friction, P suffix F is equal to, it is actual effort minus ideal effort, because actual effort is more. Again for ideal effort I'll derive the formula from mechanical advantage is equal to velocity ratio. Therefore mechanical advantage is load upon effort equal to velocity ratio. Therefore P I'll shift it onto the other side. VR comes here. So W upon VR is the formula for ideal effort. So therefore P suffix F is equal to P minus W upon VR. I'll put the values here. So therefore P we have found out the value was 25 minus W is given in the question, it is 200 divided by VR was 20. So from this I will get effort lost in friction and my answer is 10 Newton. This is the second answer, and as we see both the questions have been solved, that is we have calculated the load lost in friction, answer is 300 Newton. Then ideal effort, the answer is, the ideal effort will get it as 10 and your effort lost in friction is 10 Newton. So here we have effort lost in friction, which is 25 minus this value is actually 200 divided by 20, that is 10. So my answer is 15 Newton of effort lost in friction, and from this 200 divided by 20 is nothing but ideal effort, and ideal effort is equal to 10 Newton. So I have calculated both the values. Load lost in friction is 300 Newton. Ideal effort is 10 Newton. This is my second answer. And I have also found out effort lost in friction, my third answer. With this, we complete the problem.